I want to do a quick overview of the logic project. Remember, this is found in Blackboard. You can do it as many times as you want, and only your best score will count. Um, let's see, what else do I need to tell you? You should use your notes. The questions don't change, so just watch for that. And I wanted to record this just because I'd previously had just a bunch of videos that said, here's, how to do this stuff. I want to go through the questions themselves so that you know what you're up to. So looking at this first question here, basically you have 16 columns and you have 16 statements, and your goal is to match these. So if you look at P and Q, the standard truth table for P and Q is true, false, false, false. Looking across the row here, I see that true, false, false, false is, oh no, I went past it. Hold on, y'all. True, false, false, false is right here. It's number 8. So for P and Q, I just want to put the number 8 in the blank after it. Okay, then next, I want to look at, it is not true that P and Q. Well, it is not true that P and Q should be false, true, true, true. False, true, 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 because they're the opposite values. Is here it's number 9, so I want to put number 9 in the box after that. All you're doing is going through these 16. You should have one number in each of them, and each number should appear only once in each of them. Okay, so that's question 1. Question 2 asks you about this statement. So you need to look up, if you don't remember what a tautology, a self-contradiction, or neither is, probably do the truth table for this thing and then figure out which of those 3 things it is. Okay, for number 3, here's a new symbol. It's NAND, or the Sheffer stroke. So I have at the top of the problem the truth table for it. So for the inputs here on the left, right, so the input's P, the input's Q, 1 and 2. If the first input's true, the second input's true, the output's false. If the first input's true, the second input's false, the output's true. First input's false, the second input's true. False, true gives me true, and then false, false gives me true. I just want you to use this just like you'd use the AND table or the OR table when you first learned it to fill in this truth table below. Okay, so do the negation of P, and then take that column, take Q, and look up the values on this table. Okay, that's what this problem is. I know you've never seen NAND before. That's why I have that truth table at the top of it. Sorry, some of you have seen NAND before, but for those of you that haven't, all I'm asking you to do is apply that table that you've got right there to the problem below it. The next 2 problems are very similar. On number 4, I give us the official table for exclusive OR, and I give it a symbol. It's a little circle around a plus. And I give us the truth table for NOR. It's the negation of OR. It's Peirce's arrow. It's an arrow pointing down. And I want you to use those 2 symbols to fill in the truth table below. Okay, for example, this first column, P XOR Q, well, if P is true, Q is true, I see that that should be an F. Looking at the XOR table. If P is true, Q is false, I see that should be a T. Apologize my poor skills with the mouse. If first input's false, second input's true, false, true gives me a true for exclusive OR. And then finally, false, 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 false gives me false. So that should be the first column here, false, true, true, false. Then I need to negate that. Then I need to take this column, P, and look at this table. Okay, then for 5, I ask you to throw it all together. Here's the table for NAND, the table for XOR, and the table for NOR. Can you fill in this truth table with those 12 values? On number 6, these are questions just like the homework from 3.6. This is a De Morgan's Law question. So is this one, so is this one. Here's where I switch from going to write an equivalent statement to negate it. So to negate this, you just do the not of it, and now I've got a De Morgan's Law question. Watch, I was kind of mean on less than, greater than, less than, or equal to down here, so make sure you're picking the right one. Okay, on 12, these are questions that we actually did back in section 3. I'm going to say 2 and 3.3 perhaps. Let's see, no, these are truth tables. 3.3 for sure. Okay, but the idea is I've got a value for x is 5. I've got a value for y is 21. X is less than 5, that's false. 21 is greater than or equal to 10, that's true. In between them I have an or, false or true, gives me a true. So number 12 should be true. Okay, that's all you're up to for 12, 13, 14, 15. 16, 17, 18, 19, and 20 are a little different. This time I'm giving you some kind of equation, and I want you to put values in for it. So here, if I put 1 in for that, I'd have 1 is less than 5. I think I can write this out with a mouse. I guess that'll give me time to catch up on my subtitling as I do this. And 2 times 1. Feel free to skip to the next one. Oh, it's less than something. Yeah, I can't do it. But basically, put 1 in here for x. 1 is less than 5 is true. 2 is less than 10.7 is true. True and true is true. And then the square root of 5 times 1 is, I don't know, it's a little more than 2, but definitely less than 3. So that's false. Here I have true or false. This first one is true. Same for 18, 19, 20. 21, this is the one where I'm going to replace these with values, right? So maybe z equals blue is p, so this is p. X is greater than or equal to 5 is q. So this is p or q and p. And then I would make this truth table and then figure out which, if any, of these statements are equivalent to it. And that's the same for 20, 21, 22, and 23. 23 is just a lot harder. One hint on 23, value 1 is less than value 2 is a single statement. Okay, you should only end up with a P and a Q here as you do number 23. Hopefully that gives you enough to do this decently. If you have any questions or get stuck, please email me right away. And hopefully, like I said, this will help you out.